Welcome back to the SQA Advanced Higher Maths course, and today we'll be looking at 2.2 Logarithmic differentiation. Now, logarithmic differentiation is a method of differentiating slightly more complex functions, or functions which have something to the power of something, and which makes it more complicated to differentiate using the methods that we know so far. So, basically, logarithmic differentiation just consists of taking the natural logarithm of both sides and then using the laws of logarithms to simplify the whole expression, and then 99% of the time using the fact that the derivative of ln of x is equal to 1 over x, along with some product, quotient, and chain rules. So, in advanced higher exams, if a question is asking you to differentiate a function of the form y equals fx to the power of g of x, so some function of x, right? Let's say 3x or even 2 to the power of g of x, so another function containing x this time. So for example, 3x to the 4th plus 1 or something like that. Then you must use logarithmic differentiation. Otherwise you will not be awarded the marks if you use something such as chain rule. However, logarithmic differentiation can also be used for more complex questions which you think it would help to use logarithmic differentiation, even if it's not absolutely required, and you can still get the marks doing it another way. It's just for your sake it'll be quicker and simpler to do it using logarithmic differentiation. So, let's look at an example. Let's say that y is equal to 3 to the power of x to the 4th plus 1, So y equals 3 to the power of x to the 4th plus 1. Now, and then we're asked to find the derivative of y with respect to x. So, this is clearly in the function, in the format f of x to the power of g of x. Therefore, we must use logarithmic differentiation. Now, the first step in logarithmic differentiation is to just take the natural log of both sides. So ln of y is equal to the natural logarithm of 3 to the power of x to the 4th plus 1. Now, you should know, in fact you will know from the laws of logarithm, that the logarithm of a to the power of b is equal to b times the logarithm of a. So this means we can simplify this to ln of y is equal to x to the 4th plus 1 ln of 3. Now, this is when we need to differentiate both sides with respect to x, which is sort of in some ways a trickier line. And this is when implicit differentiation comes in handy, because to differentiate ln of y, you can't just say that's equal to 1 over y. We need to use a chain rule, like we learned in the last video, and apply it to the fact that y is a function of x. So let's look at just ln of y on its own. ln of y. So you could call the outer function u is equal to ln of x, right? And v is equal to y. So u prime is equal to 1 over x, and v prime is equal to, well, the derivative of y is simply dy over dx. Now this can get a bit confusing that there's x's here, right? When we put x's here, it's just a placeholder for any variables that's going to be put into here, okay? Whereas the y here specifically means the function of x that we have here. So it can get a bit confusing. Now, this means that the derivative of the natural logarithm of y is going to be equal to u prime of v times v prime, which is equal to, in this case, 1 over, so that's u prime of v, so 1 over y, times dy over dx, which means that the left-hand side is going to be 1 over y times dy over dx. Now the second side is going to be using the product rule, In fact, no, it's not going to be using the product rule. It's actually simpler than it seems. Let's say we expand the brackets. So this becomes x to the 4th ln of 3. I'm going to invade the other space, just like ignore this. X to the 4th ln of 3 plus ln of 3, right? Because we're just expanding the brackets. But we need to remember here that ln of 3 is just a constant, right? It's, well, I don't know what it's equal to, 1 point something, but it's just a constant. And the derivative of a constant is equal to 0. So this part just disappears when we're taking the derivative. And this here, we're not using any product rule, because this is just a constant times x to the power of something. So it's like we had 2x to the 4th, 14x to the 4th, but here we just have ln of 3x to the 4th. So this is just a power rule, equals 4 ln of 3 x to the 3rd. And so to get dy over dx, well, it's equal to, so we multiply both sides by y, 4 ln of 3 x cubed y. But now, that's not all, because we may be asked to find the function in terms of y. In terms of x, sorry, we might be asked to find the derivative with respect to x in terms of only x, but here we have y in the equation. So, have a think about how we could get rid of this y. Well, it's actually as simple as substituting in the value for y we have here, right? We know that y is equal to 3 to the power of x to the 4th plus 1, and so that's the same here. This is the same y as a y here. So this is simply equal to 4 ln of 3 x cubed times 3 to the x to the 4th plus 1. And so that's our answer for the derivative of y equals 3 to the power of x to the 4th plus 1. Now, let's look at a slightly trickier example that doesn't have the simple format of something to the power of something. That's pretty vague. Something to the power of something. Of f of x to the power of g of x. This one, though, can be heavily simplified using logarithms. It'll be much simpler to use logarithms. Otherwise, you'll have to use about 3 chain rules inside each other, plus product rule, quotient rule, whatever. So it's much easier to just do it as taking the logarithm. So this question is going to be, let's say that y is equal to, let me think, square root of 4x minus 1 divided by 2x plus 1 cubed, alright? And then we're asked what's the derivative of y with respect to x. Now press pause, have a go and see how far you can get. Just remember, take the logarithm, natural logarithm first, then simplify using the laws of logarithm, and you'll see it'll actually be quite an easy problem once we do that. So, this can be rewritten as y is equal to 4x minus 1 to the power of 1/2 divided by 2x plus 1 to the power of 3 over 2. So we're just stating that the square root of a over b is equal to the square root of a over the square root of b. So here, and now we can take the natural logarithm of both sides. So this means that ln of y is equal to ln of 4x minus 1 to the power of 1/2 divided by 2x plus 1 to the power of 3 over 2. Right? But laws of logarithms, people, laws of logarithms. And so the logarithm of a over b is equal to the logarithm of a minus the logarithm of b. So this is equal to ln of 4x minus 1 to the power of 1/2 minus the natural logarithm of 2x plus 1 to the power of 3 over 2. But that's not all, because the logarithm of a to the power of b is equal to b times the logarithm of a. So this means that ln of y is equal to, we can put this power here, 1/2 ln of 4x minus 1 minus 3 over 2 ln of 2x plus 1. So there we go. And now this is when we differentiate. Now, ln of y, its derivative is still equal same as example before. So that means the left hand side, let's move this here. So we take the derivative of both sides and we get it 1 over y dy over dx is equal to the derivative of this business minus the derivative of this business. So let's look first at the derivative of this business here. Let's just bring it down here. So half ln 4x minus 1. Now this will be to a small extent the chain rule, although by now you might be able to just instantly see the answer, the fact that it's 2 divided by 4x minus 1. It might be obvious to you by now, but let's see why. So the outer function, we're going to call it u. In fact, sorry, the half isn't part. The half is just a constant that we can bring back at the end as well. So half ln, so equals ln of x. V is equal to 4x minus 1. So u prime is equal to 1 over x, and v prime is equal to 4. So by the product rule, the whole business is going to be equal to u prime of v times v prime, which is just equal to 1 over v, which is 4x minus 1, times 4. Then don't forget the 1/2, it's a constant here, it just comes back here. And so since the 1/2 and the 4 multiply to give 2, this is just equal to 2 over 4x minus 1. So 2 over 4x minus 1. Now you can solve in a very, very similar fashion for the other side. So I'm going to let this as an exercise for you to do yourself if you want to go through the working. Otherwise, it's equal to 3 over 2x plus 1. And so this is actually most of the work, all of the tricky work. Anything from here is National 5 or even National 4 level. It's just simplifying this fraction to make it look nice and bonny. So let's look at how to simplify this. Well, we need a common denominator, right, to do this subtraction. I'm going to bring it up here. And so 1 over y dy over dx is equal to 2 times 2x plus 1 divided by 4x minus 1, 2x plus 1. Right, so we just multiplied this equation here by 2x plus 1 over 2x plus 1, which is just 1. That's why we're allowed to do this. Minus 3 times 4x minus 1 divided by 4x minus 1, 2x plus 1. So here we just multiplied by 4x minus 1 divided by 4x minus 1, which is equal to 1, so we're allowed to do that as well. Which means that 1 over y dy over dx is equal to, so now we can actually do the subtraction. I'm going to expand the brackets in the same step. So it's equal to 4x plus 2 minus 12x, and so this is minus, so it's plus 3, divided by 4x minus 1, 2x plus 1. And now this is equal to, if we simplify the numerator, 5 minus 8x divided by 4x minus 1 times 2x plus 1. But we're not quite done yet, because we want to solve in terms of just x, right? dy over dx in terms of just x. And so when we multiply by y, so times y, we can actually just multiply by the original problem here, because y is equal to square root of 4x minus 1 divided by 2x plus 1 to the power of 3. And so this simplifies to dy over dx is equal to 5 minus 8x divided by 4x minus 1, 2x plus 1 times square root of 4x minus 1 divided by 2x plus 1 to the power of 3. And now this simplifies too simply, so I'm gonna build an answer first. In fact, no, I'm gonna show the steps first. So what we want is to have, well, in fact, we don't need a common denominator because this is multiplication. Sorry, that's my fault. This is actually equal to 5 minus 8x, index form will help, divided by 4x minus 1, 2x plus 1, times 4x minus 1 to the power of 1/2 divided by 2x plus 1 to the power of 3/2. Now, so it's 4x minus 1 to the 1/2 on the numerator, and on the denominator it's 4x minus 1. So which means it's going to end up as 4x minus 1 on the denominator, because we have power of 1/2 on the numerator, power of -1 if you want to see it as that. So multiply those, it's power of -1/2, which is equal to just the square root on the denominator. It's equal to 5 minus x divided by square root of 4x minus 1. And then here, 2x plus 1 to the power of 3/2. This is just the same as 2/2. So since they're both on the denominator, we can sort of add them together. And so we get this to the power of 5/2, which is the same as the square root to the power of 5. So times the square root of 2x plus 1 to the power of 5. Don't worry too much if you didn't get the final simplification. That's just algebra. It's not really the point of this video's lesson. As long as you understand the process up till roughly here and above, then you're fine. This is just sort of algebraic manipulation, which you'll get very used to after doing a billion practice questions. So see you in the next video for some more fun.